Hello, everybody, and welcome to our continuing customer success webinar series. Today's session is a partner spotlight with our faction partners, who we've worked quite closely with over the last little while. These sessions are bi-weekly and available via Zoom invite, as well as streamed live on Twitch TV and made available on YouTube afterwards. Like I was just talking about earlier with the people on the call, we have hit 100 subs on YouTube, and hopefully people can continue to sub. But so we have our own custom URL, which is VMware Cloud Customer Success, youtube.com/VMware Cloud Customer Success, if you're looking for it. Alternating weeks will be Twitch office hours, hosted by the customer success team, discussing many aspects of the VMware Cloud offering. My name is Matt Vandenbeld, and I'm a customer success architect on the VMware Cloud Customer Success team. On behalf of the VMware team, I'd like to personally thank you for investing your time with us today. In today's session, we will highlight our partner faction, as I mentioned, and their VMC offerings. Disaster recovery may conjure up images of tsunamis crashing into your data center. You may think of cyber attacks, hard drive failures, disgruntled employees causing destruction of data, or even simple human errors, which I actually think probably the human errors is the most common part of this. Whatever disaster you fear, you know you need to protect your business against the unexpected. So before I go ahead and introduce our speaker, here's some housekeeping items. All guests are muted. Please post the questions using Q&A feature at the bottom of the Zoom, and we will respond throughout the session. Now I'd like to introduce today's speaker, Matt Wallace. Matt, do you want to give us a little bit of an overview of yourself, and then you can jump right into it?
Sure, absolutely. So Matt Wallace here. I am the Chief Technology Officer for Faction. We're a longtime VMware partner, been around since 2009, and we began in VMware's cloud program, building and operating hosted private clouds, where we've gotten significant scale, thousands of hosts, over 100 petabytes of storage under management, and I myself am an ex-VMware person. So it's always nice to kind of be looped back into the ecosystem. And I'm excited to talk about all this stuff today. Back in my VMware days, I did some of the early work on vCloud hybrid service that became vCloud Air. And so when I first learned about VMware Cloud on AWS, I became really excited because I thought, wow, this is the sort of dream offering, putting these properties together.
I agree.
All right, well, let's kick it off. Like Matt said, happy to take kind of questions throughout here. So let me just dive in a little bit about Faction. So like I mentioned, we're a service provider partner, premier tier, which is the top tier for service providers. We're a technology alliance partner with VMware. And then I think really importantly for VMware Cloud and AWS, we've been really doing this about as long as it's been there to do. We were basically the first service provider to turn up an STDC, and we've been participating since the Lighthouse betas in mid-2017. So we've learned a lot of things along the way. And even before we were participating, we had kind of big plans around the service. And I think really interestingly, too, we are also an AWS Advanced Consulting partner. And the only reason I mentioned this, and it's relevant for a lot of use cases, but DR in particular, is a lot of folks who have these like deep roots in the VMware ecosystem, they don't necessarily have a lot of kind of public cloud shops. There are a few, but sometimes it's the ne'er the two shall meet kind of situation.
Yeah,
We've been able to do some really cool.
Just to jump in there a little bit with our experience too. So we actually see that as well, but a lot of times even the customers that have that experience, it's a completely separate team that doesn't talk to the VMware team. So even if the companies have that.
It's funny you should say that too, because I've definitely engaged with a lot of customers and prospects where their VMware team is driving the VMware Cloud at AWS, and they tell stories of kind of evangelizing the offering, right? Because they have a team that's already using AWS native services, and they talk about, we told them we were going to move this environment there, and they could get super low latency access to the database now, and they were shocked, and it's really cool to kind of hear the stories about how the way that those two separate teams work a lot more closely together after some of those workloads move to VMware Cloud.
Well, we are the bridger of gaps, I suppose.
For sure. So what's interesting about this, AWS chops really here is it really lets us build holistic solutions. We've done a lot of things, and we'll talk a little bit about this here in the slide deck. But being able to leverage those Amazon services and being able to ready to use things like Route 53, CloudFront, load balancers, all that sort of things to build true like hybrid topologies where you have all that, VMware environment flexibility and power, but also be able to layer in some of those Amazon services, I think is one of the best things about the offering. So why disaster recovery? Um, you mentioned this in kind of the intro, and of course, the data center catching fire or springing a leak is certainly one of those things. But increasingly, we find that things like ransomware, which I grabbed a screenshot of here, becomes a driver for disaster recovery. Right? What are you going to do when this happens? So there's also human disasters. Back in my earlier days, I spent a while running development teams, building web applications, and I can still remember the day when the site suddenly went down and I discovered a developer had managed to drop the users table out of production. That was a fun recovery effort. So you name it, whether it's human or natural disaster, DR is one of those things where if you're not prepared for it, it can be very costly. So, um, so you assume that disaster recovery is important, right? You want the resiliency for your IT efforts. Then you ask, why DR2 the cloud? And I think this is where a ton of the interesting growth has been in terms of disaster recovery, and it's such a natural fit. So of course, with public cloud, including VMware Cloud and AWS, you've got this geographic diversity. You have all these choices for data locality. You can land it in many countries. You can scale across multiple regions, but you know that you're getting that full operational consistency across all of those and that scale. I think AWS is now up to 20 regions globally with 60 availability zones, and they've got more on the way. And just knowing that you can kind of scale across all of those and move between all of those is a pretty powerful proposition. I think cloud services, and this is something we touched on just a little bit there, talking about AWS, native services, but it really helps when you're doing, DR topologies. Like we had a client where we set up an environment for them in VMware Cloud, and they had Palo Alto firewalls that they were using. The key functionality they were using from those was WAF. And when we set up their VMC environment, we were able to use AWS WAF so that they didn't have to go and buy additional appliances or run additional virtual appliances or keep those things in sync, because it meant that need for them. And of course, there's lots of other AWS services that kind of factor into that. Scale obviously is a huge thing. When you're operating at public cloud scale and all these, hosts can be used in sort of different ways. One of the amazing, great things about that is just that there's a lot of capacity, and so recovery at scale becomes a much more minor point even for larger enterprises. And then of course, the DR software to the cloud. So if we conjure up the last decade version of disaster recovery, it often involved additional data centers, additional teams to buy additional equipment and stand it up and operate it, additional round of patching, all those sorts of things. Obviously, get rid of that with the cloud. But now the DR software that's kind of doing this means instead of having having to script and build your own runbook, you have these tools, like Site Recovery, that allow you to essentially script a runbook without being, particularly radically technical. Being able to choose, what am I going to recover, in what order, do I need to wait between these pieces of recovery, all those sorts of things. So you end up with lower RTOs, less risk, higher ability to test things and ensure that things are going to come up as you expect. And of course, one of the great things about the VMware environment, in particular with Recovery to the Cloud, is it makes it pretty easy to do things like, hey, if I'm going to do a test recovery plan, I want to remap these networks so I have everything sitting on a DMZ so it doesn't interfere with production. Things like that are really powerful. So if we establish that DR to the cloud is good, hey, what are some of the bad things about DR to the cloud, right? Or what are some of the the pitfalls that people run into? And to talk through this here, import issues is a big one, and this really has to do with the tools that people use. So there are a lot of ways that people are doing DR to the cloud today, right? I don't want to go and make it seem like site recovery is the only way that people are doing things. And so what I'll say is, having looked at a lot of the other tools that recover directly to public cloud, one of the biggest issues is they often rely on having to import VMware workloads through the public cloud service, right? Those things don't translate, VMX and VMDK VMware formats natively. So if you want to turn them up, they run through the importer process. There's two problems with the import process. The first is it can be time consuming, right? Amazon, for example, limits the number of concurrent import processes by default to 5. And then there's some time to actually do that import. And then on top of that, there's an issue of if you convert it, is it going to come up 100% of the time? And even a risk of, hey, even if I tested the recovery, if I make a change to the source, might it also have a problem at recovery time? And the tool set here is certainly improving over time, trying to kind of transcend that hypervisor barrier. But I think for the highest assurance, you still have to classify that as a risk. So tool compatibility is another one. And this really just has to do with, hey, we know that a lot of these on-prem VMware environments, one of the great things about VMware is this big ecosystem of tools that have sprung up around it. And so if you're using a specific tool, whether that's for VDI orchestration or for backups or whatever, you go and fail over into a public cloud, you basically, it's a good chance you're losing your tool set because it's not integrated or integratable with the public cloud in the same way. A lot because VMware has provided its alliance partners, with access to the hypervisor in careful ways in order to do those integrations. APIs that allow things like copying your VM data for backup purposes and so on. Of course, RTO time is an issue. That could be because of conversion, or it could be because of data movement. Obviously, there's a lot of things that do recover to the cloud where the data gets stored in like an object storage format, incremental changes going into object storage. And then when you want to recover, you actually have to fetch them out of object storage and kind of reconstruct the virtual machines even before you run through an import process. And then the last thing here, and to me, this is the thing that's most risky about sort of the first wave of DR to the cloud, prior to site recovery, when you're looking to do this recovery in a public cloud, which is the recovery process, is you have to think about this and imagine it, right? Something dire has happened and you are trying to do a disaster recovery. This is the thick of battle, right? You're trying to get your workloads back online. Pressure is high. There's going to be a tendency to have that hair on fire moment. This is the wrong time, absolutely wrong time to ask your team to completely change tools from what they're used to using all the time every day to a completely different technology stack. Even if you are following the absolute best practices and you've done tests and you've done the drills and you're familiar with it, there's still that muscle memory you get from working with a technology stack day in and day out. And if something is going wrong, your team probably has a high ability to kind of diagnose those edge cases in the original environment. But you're suddenly making this radical change to turn it up in a totally different environment. Now is not the time to change your tool set, because if something is going on, you really want to be able to address it just like it's on-prem. So I think that's a real concern around DR to the cloud. So obviously, we're going to kind of talk about how VMware Cloud and AWS helps solve this. And I kind of feel like if people are tuning in here, they probably are familiar with VMware Cloud and AWS, but I did want to just kind of zip through some of the features and benefits just from the faction perspective. And I'll give you the take maybe on one of the things some of the stuff we love about it, and some of the things we've heard from our clients. So, of course, that SDDC delivered as a cloud service on Amazon, and it, underneath it all, it's like you understand what forms of VMware SDDC, and it's great because you're getting that exact same experience, right? You're logging into a vCenter. It could be your cluster in your own data center, for how easy it is to interact with, and that feeds into that consistency and familiarity, right? Part of this is about making use of skills that you have. Obviously, there's north of 60,000 VCPs out there that have deep experience running environments with this tool set. But also, all the ancillary tools, right? They might be familiar with things like, offerings from partners like a HighTrust or Palo Alto that are well integrated into the VMware ecosystem. And obviously, those integrations let your team do a lot more with less. And so that consistency and familiarity, again, lets your team do more with less. That's especially true in VMware Cloud and AWS, right? Because VMware's taken so much of the grunt work out, right? Building the cluster, patching, the maintenance, scaling up, those things are tough operations on a team. Thinking about, when we operated and do operate private clouds, that kind of hardware maintenance, the patching, those sorts of things, that actually is some of the most difficult and time-consuming parts, right? There's so much work that goes into validation, regression testing, and so on. And the fact that VMware has just completely taken that, off of your chest is like a huge benefit to what your team can get done in a certain amount of time. Obviously, workload portability. So, I mean, we've had plenty of conversations with people who are like, hey, we've been wanting to move to AWS, or we've been in this process of moving to AWS for quite some time. Um, Now that we've kicked the tires on VMware Cloud and AWS, we realize, hey, this is going to let us do the move now. And that's true. That ability to kind of take an existing data center and either extend it or migrate it into VMC is just an incredibly powerful capability. But then you get this direct access to native AWS services. And this is where I think this is much more than a hosted private cloud offering, right? Because, and I'll rewind the clock a tiny bit here too, because Faction actually was focused a little bit on this hybrid area before. We offered private clouds. We had them in areas where public clouds were located, like Reston, Portland, Santa Clara. And we still have an offering where we can connect those directly to the public cloud over direct connect connections and so on in a very seamless way. But at the end of the day, this VMware Cloud data center, this SDDC, is inside of Amazon's data center. So the latency is effectively zero. And that elastic network interface that connects the VMware environment to the Amazon services, there's no charge for flowing over that. So you're getting basically zero latency, no ingress or egress fees. And that's a really powerful offering to build true hybrid and then link things into stuff like CloudFront, for example. So we have, some clients of ours using north of half a dozen AWS services every single day alongside their VMware environment in VMware Cloud. And then, of course, you've got this really seamless transition here because you've got the ability to obviously run your traditional VMware workloads where it's just virtualized virtual machines, but then you can build container infrastructure and actually do things with containers on both sides of that equation. So that's really powerful because this is really future-proofing your VMware environment with all the stuff that's kind of coming out. I think it fits great too in the larger VMware ecosystem where you have access to other tools like Cloud Health to manage your spend, things like Wavefront to do monitoring and alerting and analysis of workloads. So that's all pretty cool. All right. So this is the kind of architectural overview, and I like showing this. This is our version of this slide, and you've got obviously the customer premises piece on the left here, because of course you can continue to run your own VMware environment and then attach it directly to VMware Cloud and AWS over hybrid linked mode, right? So that vCenter on-prem and the vCenter that you run in VMC become that single pane of glass, and you have that familiar vSphere, vSAN, NSX taking those bare metal hosts from Amazon, the i3 metals or the R5s, and converting them into SDDCs. And then I highlight, of course, that interconnection, that elastic network interface that AWS uses to kind of plumb between the native Amazon VPC and the VMware Cloud on AWS VPC that kind of connects you fast and secure across those links and gives you access to all the services. Did a booth presentation actually back at VMworld and reInvent around actually accessing RDS from inside of VMware Cloud and AWS. So it's like a use case where rather than running your own database server, and maybe you did have it as a VM, you could actually convert it, migrate it into RDS or Aurora on the Amazon side, even use serverless Aurora, let Amazon take care of the scaling aspect of that, and just access it across that ENI. Now you have a scalable tier of an AWS native service, but you can actually do some things on your side that look architecturally the same. So,
Well, and along those lines too, there's a little bit of it going the other way too. So RDS is coming on-prem as well as some of the other services. So there's kind of that fluidity now between that VMware Cloud and that AWS stuff. I don't know, it's a little bit off the topic, but I thought I'd mention that as well.
No, literally, probably my favorite announcement. And I hear lots of things, obviously, but the RDS thing took me completely by surprise. Super, super cool. Really speaks, I think, to the depth of the Amazon VMware partnership from our perspective. It was really exciting to see. I did immediately start asking, hey, when can I have SQS on vSphere? So we'll see if the innovation train continues. But I think it's amazing. And when you start thinking about the context of the upcoming Outpost offerings, really cool that the partnership is deepened that way. So I think one of the things that we'll just highlight here is, hey, this is rapidly spreading to all 20 of the regions that Amazon has, and then coming in lockstep with new regions, and that's powerful. It's literally like your enterprise suddenly has 20 data centers that you can turn a workload up in around the world. So that's a kind of a big deal. So we've gotten through the introductions, right? And I want to talk now, obviously, about the DR piece. So site recovery, VMware Cloud and AWS Site Recovery is a fully managed offering that VMware has rolled out, where they basically turn up all the components of site recovery service on the VMware Cloud and AWS side. So the SRM server, the vSphere application appliances, have those things linked together, patch them, etc. And then the licensing, when you sign up for that in VMware Cloud and AWS, it gives you the downloadable on-prem components. That's all part of the bundle. And then you can basically immediately start delivering RPOs as low as 5 minutes with that. So Site Recovery Manager, most people are probably familiar with it if they're tuning in here, but it gives you that ability to do the automation and the run booking around that. In this case, obviously, it's all built into VMC, but it then gives you a big tool set. And I took a few screenshots here, right? So you obviously have on the left-hand side a view of the actual GUI where you can click and run tests, where you can go and view the history. The run books allow you to kind of prioritize all these things here. Like I've truncated on the bottom, you can see power on priority 1 VMs, and there's some ability to do custom scripting in between. And then the other cool thing, of course, is that when you're doing this, you can actually take, for compliance purposes, for example, let's say you're a compliance suite, an ISO, or even contracts with your customers require you to show, yes, we actually have a DR site and we can execute a recovery. So, site recovery makes it really easy then to export that out in a format where you can go and work with that. And when there's other steps involved, and we obviously do, in our managed DR offerings, we do some more complicated things. We actually export, the runbook out of site recovery, and then we can build some additional steps into the runbook. So, for example, we have clients that are replicating NAS from on-prem, right? So part of our runbook might be to break the replication relationship from the on-prem NAS to make that NAS service available to the guest VM, so it looks like on-prem. So those are the types of things that we can then inject into the runbook, but I think it makes for a really good start. So just to talk about why site recovery in particular, right? So compatibility, this is the big thing here. The vast majority of your tools from on-premises are going to work, and they're going to work in an operationally consistent way, because at the end of the day, this is a VMware environment. It's operating very similarly, if not exactly similarly, to on-prem. Obviously, you may have a slightly older version, of some tool, that sort of thing. But by and large, the benefit of having the same tool set is pretty strong in terms of compatibility. The full cloud recovery. So, this is the biggest reason in my mind to recover to the cloud in the first place, right? You don't need to have a full second site. You have the scale of Amazon underlying that, and we have some actual statistics in this deck because we've done some testing on this, and we'll cover how fast it scales up, which is pretty darn fast. But basically, when you look at what it takes to boot VMs and how fast site recovery can just execute on the plan, powering things up, the SDC can scale up almost just that fast. So it's pretty strong there. And this is arguably the most important thing about site recovery service versus other recover to the cloud options, is that you have this ability to fail back and reprotect. You're not, if you look at some of the other tools, and I don't want to name names, but if you look at other recover to the cloud tools, you may find that the fail back process is things like export the virtual machine and then run it through converter in order to put it back on-prem. Things like that obviously do not lend themselves to a seamless experience, and it means you're essentially signing up for an extended maintenance window to get back on-prem. Whereas with site recovery, you have the ability to reverse the replication relationship, send those changes, the deltas back, and then cut over very seamlessly and in a coordinated way. And then I've talked about this a bunch, but obviously all those Amazon services like the load balancers, the content delivery network, Route 53 DNS, the extensibility they offer and the kind of scriptability around those because of the APIs and CLI tools around those just make it a lot easier to construct a DR offering. And obviously when we're doing fully managed disaster recovery, we're actually setting up a lot of these things for clients like ours, like Route 53, and using DNS failover with Route 53 that's already scripted into Amazon, for example. So to talk about this, let's think about DR, and I just put this together to kind of give a view of the kind of spectrum of D offerings, because we've got everything from the, like, on the left here with cold standby. You might even think of this as like offsite tape backup, right? Yeah, it might take you 24, 48 plus hours to recover, maybe longer depending on how big the workload is, but it's inexpensive. Storing tapes is relatively cheap. Then you've got kind of stepping up to this very like hint of active, secondary site here, right? The pilot light, and we call it the pilot light because it's just like your water heater, right? You have a little bit so that if it kicks on, it can start heating immediately. And so what we see a lot of times is that folks have a very, very small kind of critical, set of virtual machines they really, really want to run in a secondary site. Things like secondary domain controllers is probably the most popular thing that people want to have a second copy of, because Active Directory doesn't always behave really well when you kind of pull a copy up out of DR. And that's especially true if there's another copy that's kind of running and you're doing a test. Nobody ever wants to see two systems that both think they're the same domain controller trying to talk into a domain, because that can cause some serious issues. But VMware Cloud on AWS obviously lends itself to that, because you can have the kind of minimal cluster size and then scale up. Likewise with warm standby, and now we're getting into the active passive model. It really depends on if you need this, depends on how big of a kind of warm footprint you need. In a lot of cases, people want to run effectively a secondary site, like something that it's almost like a full active topology, except they are not sending any traffic to that warm standby. And so, it's sort of ready and hot and able to take traffic immediately, and it has all the sort of critical business functions. But if it received a production workload, it would probably essentially be locked up because it needs to scale more. So scale up active here. This is an idea that you're actually having load on both sides, and it can actually be evenly distributed. So you might say, yeah, we're going to run this. So if there's 100% of our workload, we're going to have the capacity to field, say 70% of it, but not 100 on each side. So you're actually designing an active topology, but it's not enough, for peak load at all times. But you're counting on the ability to scale up the secondary site, or each side, I should say, because it's not really primary, secondary at this point. But you're counting on the ability to scale up in case of failure. Obviously, VMware Cloud works great for this. That ability to scale up the SDC really quickly is a big deal. And then the full active, this is rare to even see this. I honestly don't know that this is something you'd see a lot of in the recover to the cloud motion, because it's not even really a recovery in a sense, because this is really somebody who is actually designing their topology for two sites always on, where if one of them fails, the other one can take 100% of the peak load regardless. So this is obviously leveraged for the absolute most mission critical type of workloads where seconds of downtime is too much. So when you think about how VMware Cloud works for all of these, and I kind of touched upon this, but cold standby, if you have a way to land your data, you obviously can turn up an SDC completely on demand. It takes a little bit more than 90 minutes to create a fresh SDDC. And if you happen to have a one node, which obviously one nodes are not durable, so there's a consideration there, but you can scale a one node up in about 20 minutes into a full cluster.
Just to drop a note in there that might be changing that will be changing here in the very near future.
Yes, I'm looking forward to the future innovation. And of course, we saw the cluster size shrink from 4 to 3 as well. So I think, as we get more hardware types, we're going to see lots of new things here. And one of the things we do a lot of at Faction, obviously, is try to keep up with how all these things are kind of progressing. So you've got this pilot light environment. So this is, where we would see, minimum size SDDC. It's nice that it's gone from 4 to 3. And of course, right now we've got VMware's 3 for 2 promotion as well. which helps make it economical to kind of land this pilot light environment. So it gives you the immediate place to run that steady state workload, right? Secondary domain controller, things like a secondary copy of a database if you want to use something like always on availability groups for a SQL server, or actually have a MySQL, MariaDB type slave where you can fail over to that if you want to do that in a more high touch way than using the underlying tools, whatever. And actually, obviously, the other thing is, we run across a lot of clients who, when this environment isn't being used for DR, which is obviously rare, thankfully, they use it for other things like test dev, right? They can build run books that help them recover a copy that they can do some kind of testing on, and they just kind of throw away those copies of the VMs. You got warm standby, and we're really kind of talking about how much you're using of the SDDC, but since you have minimum capacity of 3 for a steady state, but you can get up to 160 hosts effectively, right? 16 hosts per cluster, up to 10 clusters per SDDC. So you have an ability to get really large if you need to. So there's a big range where you can do warm standby, and that flows directly into the scale up active. One thing I love to highlight here, of course, is you can actually be running both of these, see them in the same pane of glass, actually use NSXT to have security policies enforced, and then of course with the L2 bridge you actually have the ability to link the networks. And we find it's kind of 50-50. About half of our clients actually want to stretch their layer 2s between the sites, and actually have the exact same network on both sides and have everything communicating real time, so they can recover things and move things kind of on demand. And then some of them want to have full isolation. So they want to have the same layer 3 addresses, and they want to have completely different layer 2s so they can recover or do tests with the exact same layer 3 IPs without having the VLANs kind of commingle. So we obviously support both of those topologies. And then full active. The nice thing about full active is you do have that ability to be really operationally consistent across multiple public cloud regions. So even if you did suffer a failure on one side, it's nice that not only could you, rely on that secondary site, but you actually could, depending on where your data is, you might be able to actually spin up a tertiary copy as well, in a more on-demand way if you think the outage is going to be extended. So to share some technical tidbits here, I have no idea why this slide has this sort of fuzziness at the top. But talking about scaling, right? So I did grab a little, a little screenshot here of a 5-host cluster, with the ability to add up to 11 hosts. So you can kind of see that scale up to 16 there. But to cover for some of the technical folks on the line, cover some of our actual specific testing. So this is Faction's internal testing, things that we've done to run through this, so that we understand how to architect this. So host adds are really interesting. So if you do one, you'll see it happen in kind of 13 to 15 minutes. But if you add multiple hosts, you'll essentially see about 6 or 7 minutes of overhead time as it kind of spins up to start doing it. And then you'll see the host kick in about every 6 minutes after that. So if you want to add 5 hosts, you're looking at something like 37 minutes. So interesting result there that it becomes basically faster to add more hosts at once. Host removal is actually really fast if there's not data on it, and this is really important here, right? If there's vSAN data that's on that host with the NVMe drives, then obviously the SDC needs to evacuate that vSAN data from the node before it removes. So that really, the true removal time on a full, a more full cluster really depends on how long it takes to evacuate that data. Actually adding an entire cluster takes 29 minutes in our tests to spin up a completely new 3-node cluster inside of an existing SDDC. And then, of course, you can continue to add hosts to that at 6 minutes. And if you just provision a larger cluster, you'll see 29 plus however many minutes for the additional hosts that you add. Likewise, cluster removal is just as fast as host removal as long as the data is already evacuated. So in our test, we actually cleansed all of the data ahead of time and then remove the cluster. I don't actually know if we've tested it with the data. Obviously, there might be an expectation that if you're deleting the entire cluster, the data is going to be gone anyways, unlike with a host removal, where the data is actually going to be moved to another host. So I thought it was interesting, and it really shows how fast this is. Incredible scale-up times. So, and I think one thing that we've tested repeatedly here that isn't fully captured in this, but it actually does sit right in this thing, is how long does it take to scale up from a 1 node to a 3 node? And it really looks just like that host add time. So if you're on a 1 node and you want to make that SDDC durable and scale it up to a 3 node, it looks basically about 20 minutes, right? So the double 2 host adds, right, with 6 minutes per plus 7, we'd expect that to take roughly 19 minutes. So this is something that I have some real joy about. We've done some really cool stuff integrating with native AWS services. So this is an actual topology from a client of ours where we built, their users coming in through Amazon's internet, hitting the application load balancer. They actually had a small piece of an application that was running in the native EC2 VPC stretched across availability zones. And then a lot of that workload then flowed back into the VMware environment in NSX and into the rest of the application that was running inside of the VMware Cloud VPC. On top of that, they were using CloudFront for content delivery. We used Route 53 for their DNS. We're using WAF to secure some of the web traffic coming in. I didn't list it here. We also issued their certificates with Certificate Manager, things of that nature. So this is one of the coolest things. I think it really highlights the power of using VMC. And now, not to bury the lead, but getting into, so how does Faction help with this? And I think maybe some of this is remedial for folks that weren't through. But if you were interested in VMware Cloud and AWS, for disaster recovery purposes, Faction has really gone and done some work to help make this a lot cooler. So VMware basically built an integration with one of our products, which we call Cloud Control Volumes. And you could think of it as a NAS array for the cloud, essentially. Or we have storage arrays that export NFS storage that can be mounted up from public clouds directly. And obviously, the cloud in question here is VMware Cloud and AWS. So we have big lags that use Direct Connect to export data that VMware Cloud and AWS can consume. So this, we've been working on this feature together. I mean, I think, for more than a year now, really, and it's going GA. And what it does is it effectively takes alongside the vSAN data store that's already present in VMware Cloud and AWS, it basically gives you an added data store, completely separate capacity that Faction supplies in that cloud control volume form that mounts up as a data store into the VMware environment. So this kind of shows you how it connects. And Faction has some patents around cloud connectivity and layer 2 encapsulation that helps smooth this process out. If you look here, I've actually got a screenshot of a data store with one of those cloud control volumes mounted up. So you can see this is actually a VMware Cloud on AWS. It's a 1 node SDDC, and along with the vSAN store and the workload data store that everybody sees when they turn up an SDC, you'll see this CCV data store. So it's operationally consistent. VMware's integration with cloud control volumes means they get automatically mounted. They get automatically mounted when they scale up, add hosts or remove hosts. Those mount points maintained across all of those hosts. So you can scale up and scale down still. It supports all the normal functions. So you can use it, you can vMotion to it, you can SVMotion from it. And the data store, though, is completely independent of the cluster size. This thing here is obviously, this is a 1 node. We can scale up to 16 nodes. We could add additional clusters. All the clusters would mount the same storage, actually. And it persists even during a cluster shutdowns. In our case, we've actually just had 1 node SDCs. We'll tear it down, turn it back up, remount the storage. We can actually pull VMs there. So really cool stuff there.
I would like to add here as well that you guys are currently the only ones with this offering. So I would like to kind of highlight that which I think is really an important part to highlight is that if you want kind of storage outside of what VMware Cloud offers from a R5 or i3 standpoint, this is the game in town, and I think it's a really kind of cool solution.
Yeah, and I don't want to. I almost feel like if I get too heavy into sharing numbers, it sounds almost unbelievable. But I mean, in the customers that we're working with now on this, when we're using VMware Cloud and AWS for DR, and it is absolutely a fantastic use case because of all the reasons we've talked about. In a lot of cases, we're able to save people north of 75% on what that solution would be, because obviously, one of the great things about VMC is it's lightning fast. We have tested the performance, and just 4 node SDC in the very early days, we saw north of 160,000 IOPS across that. But depending on what your fault tolerance and erasure coding settings are, you're going to see VMware guidelines, depending on the cluster size, range from everywhere from about 3.7 terabytes of usable space to 8 terabytes of usable space per host on the i3s. And of course, you can get more on the R5s, but then of course you're also paying for the EBS storage on the back end. So I think you save 20% ish, for storage heavy workloads going to R5s. In a lot of cases, because we're focused 100% on just delivering storage across Direct Connect, we can save 80% plus off the storage cost. So by kind of combining the cloud control volumes with VMware Cloud and AWS, we can basically make the most economical DR to the cloud offering out there, still with all that operational consistency. And to your point, this is something we had the cloud control volume platform actually built and GA'd in late 2016. So before VMware Cloud was even announced, actually, this is something we were already doing for multi-cloud use cases for clients of ours that wanted to have the same pool of storage accessible simultaneously from Amazon and Azure and Google, SoftLayer, you name it. So that was kind of the original use case that we had built it for. But as soon as we found out about VMware Cloud and AWS, not only did we have a conviction that this is going to be a fantastic way to go and scale people's operations into the cloud on this platform with all this consistency, really putting VMware and AWS together seemed like is one of those "did I dream this" kind of moments, right? Because I would never have expected that partnership. But as soon as I heard about it, I was like, this is going to be incredible. But we also, when we learned more about the offering, we thought, from what we see, in our own customer base, we think there's going to be a lot of folks out there who are hungry for more storage. And so we've been working towards this, to get here for quite some time because we knew that this would be really useful. So, the CCV is obviously, they can be used for production workloads, and we actually have 3 tiers that we can offer that we call Deep, Prime, and Flash. So you can kind of select whatever service level makes sense. But we also have storage specifically designed around disaster recovery. This idea that you're going to be replicating constant changes, but when you need to go and recover, you're going to want to recover really rapidly when you do. And so I just took a screenshot here of this VM managed by Site Recovery Manager, but sitting on a faction CCV storage pool in VMware Cloud. So just kind of give you an idea. It really looks just exactly like what you'd expect, except instead of being on the workload data store, it's sitting on that external storage. And again, since VMware has automated that host add process, you can really quickly scale from the minimum cluster size, call it 3 right now. Although it can work with a 1 node, but I don't think people really want to tear it down and stand it back up over and over again. At some point, durable 1 node might be the route to go. But today, 3 and then scaling up to 16 plus hosts, really powerful here because the same storage pool is available to all of them.
So because nobody else is asking questions, I'm going to get in here. So you guys have then the automation then to attach this to every host ad. Then there's nothing manual required from a customer standpoint when you add a host and VMC to make this storage accessible.
Yeah, actually, it's not us; it's you. So VMware built the integration. So there was an engineering team that did all this work to basically add this automation to VMware Cloud. But yeah, when this is configured on the SDDC side, the same processes that are scaling up the cluster on the VMware side are also maintaining all of those data store amounts to keep them consistent.
Even better.
Yeah, exactly what you want. Now we actually do have the automated provisioning for our side, right? Can we provision a volume, the attachment to the Direct Connect, the provisioning of all the private networking that wires it in, all that sort of thing on our side is automated. But yeah, in terms of the cluster, I think that's the critical part, is that scale up, scale down operation, all handled by VMware. All right, so obvious benefits here. I think this is like, as soon as you realize this is possible, I think it becomes kind of oh, hey, shocking, but wow, of course that's going to be great, right? But yeah, I mean, the key benefit here is now you can replicate, a very large footprint of storage, potentially hundreds of terabytes of storage. And then, you can start with that minimum cluster size on the VMware Cloud and AWS side, replicate hundreds of terabytes, and then just do recovery. And of course, because it's just a regular data store, you can recover in place using it with the data in place on that faction CCV, just like you would with any VMware data store. But then, if you want to move from that DR tier into the NVMe tier for performance, then you can actually SV motion things just like a standard VMware data store. You can then pull that VM off of that onto the local vSAN as well. And obviously, if you're scaling up for your recovery, you're going to have a growing amount of NVMe storage, and you would want to take advantage of it. So it's very normal workflow. And the data stores, like I mentioned, they're accessible to all nodes for all cluster sizes, and all the SDDCs and clusters inside of an org all can leverage the same volumes. And then on the back end, of course, we have completely redundant storage controllers on our side. We're using redundant Amazon Direct Connect networking. We actually do BGP load balancing across multiple lags. So we have both redundancy to each Amazon switch, as well as redundancy across Amazon switches. When this gets provisioned, actually, the one thing that you have to do to actually turn this on, and if we're managing your environment, of course, we'll do it for you, is you have to go in, and in the networking section of your SDC, you're going to see the virtual interface requests that we dispatch to your VPC, and you have to accept on those so that we have the connectivity into the ESX environment for the storage to be provisioned. And then, in our kind of calculations, depending on various sorts of settings, anywhere from standard DR storage saves anywhere north of 80%, we'll just call it, right? So fantastic way to kind of do DR into VMware Cloud and AWS. And even if you want to have all flash storage, because you just need a higher performance level, you want to maybe run a larger amount of production workload quicker and shrink the RTO time, and have a kind of higher service level, we can still save a substantial amount of that. And then we don't know exactly about the R5 nodes, but we still think that the R5 nodes, we're guessing from what we know so far, that they'll save you about 22% off of the i3 hosts for storage at scale. But obviously still we can kind of improve on that a great deal. And then in terms of egress charges, this is important. So when you're using the faction CCVs, they are sitting across Direct Connect. So all the writes that go to that storage do end up then generating an egress charge, because as you send the byte to the storage, Amazon is accumulating that on the Direct Connect bill. So our average egress charges for those DR use cases, though, are under 7% of those i3 costs. So you're going to spend 7% of that 82% plus savings on egress charges, but obviously it still works out enormously in your favor. And just for the heck of it, we kind of grabbed a screenshot of VMware's FAQ here, just so that folks realize this is a feature that we've worked really tightly on together. And to your point, right now this is storage is provided through Faction, so this is a Faction exclusive thing right now. I think this really comes from the fact that we had this cloud-based storage platform, fully GA'd long before we realized that VMware Cloud would be a great use case for it. And you'll note here, this is preview mode. We're anticipating GA to be next week at this moment, so we're really right here about to go live with it. We've been doing EA for about 5 months now, and it's going great. So really excited about this offering. It's really timely to be kind of getting together with you, Matt, since we're about to go GA. And I think we are struggling to keep up, honestly, with the number of folks who are interested in using this for the DR use case. For all the reasons that we mentioned before, I've always thought VMware Cloud and AWS was the premier place to be doing DR to the cloud, right? You're literally getting all the things that people do DR to the cloud for, but you're getting rid of pretty much all of the negatives, right? All those conversion times, the risks of changing tools, all that stuff, you kind of get rid of by having that VMware environment that's basically marrying all the benefits of public cloud with all those benefits of going VMware to VMware recovery. And then by adding in this faction storage, we're pretty much making it super economical as well. So really excited about having been able to do this integration with the VMware folks.
No, I think it's really fantastic. And for those that caught a couple weeks ago, we did a site recovery deep dive with GS Carlson. And that's definitely, I think, one of our major pain points, as you kind of brought up, is the amount of storage needed, but tempered with reducing the cost in a non-DR event type infrastructure. I think this is a fantastic offering, and that's kind of why I wanted to bring you guys on and really highlight that yes, this is your guys' solution. So it's not like like we have our own solutions. We're working towards similar things, but if you want this right now, Faction's the game in town for it, and of course we support it because you guys run on VMware Cloud on AWS, and however you get there, we're happy with. And we've had an excellent working relationship with you guys, and I can't speak more positively about it. And I kind of like to see how much this kicks in when you guys actually GA this next week.
Yep, we've actually have a lot of clients who are onboarded basically either with the EA version or have signed up and are basically either doing some pre-seeding of data because we have ways to pre-seed the data before and just kind of waiting for those final bits. It's interesting too. It's maybe worth noting, and people might enjoy this as a piece of trivia, which is that the the GA essentially was waiting for all the NSXT rollout to be completed. So we had actually done a version of this integration for the old NSXV networking. And then obviously the attachment across Direct Connect is a really important part of the service. And so, we had to go through that cycle of making sure that everything was ship shape to integrate with NSXT. I will say from our NSXV days that wow, does NSXT makes the network integration so much easier. Really an incredible upgrade there in terms of the more complex network topologies being really easy to do with Direct Connect.
That's good. So you're done with the deck? Yeah, okay, yeah. So if anybody's got any questions, definitely you can put them in either Twitch chat or the Q&A box in Zoom. I might kind of start some of it off because I haven't seen any other questions come in. So is there any data or any region limitations currently, or is this going to be offered everywhere that VMware Cloud on AWS is offered?
Great question. Yeah, so we are supporting a subset of regions, and part of this is because we're just not everywhere that this is. Although we have pretty broad regional support, so we're starting off with Reston, that is US East 1, Northern Virginia area, plus Portland, plus Santa Clara, so US West 2, which is a kind of recent addition to the regions VMware supported, plus London. And then we anticipate having an additional site in the EU, quite possibly Frankfurt later this year, as well as our first APAC site. So we're always evaluating things like proximity and so on. There's places where I don't know that we'll ever go. Like Amazon, for example, is in Toronto, and the last time I checked on the Toronto, Canada Direct Connect times, the fastest Direct Connect you could get was still 8 to 10 milliseconds of latency. And that's really, in my mind, too high for us to want to deploy an adjacent storage platform. So if we found that there was a new data center provider that had Direct Connect that was sitting, 2 milliseconds away, then we'd be looking to do that. So
I actually thought that the
and it's
Canadian data center region was in Winnipeg in Canada.
Well, so maybe this is where the latency comes from. Maybe they
that,
call it Toronto and they do direct connect in Toronto. That's a good example, right?
yeah.
So in the United States, of all the regions, the latency is highest going into US West 2, which is Portland. And the reason why is because Amazon's direct connect equipment sits inside of Edge Connects in Portland. We're actually, our gears also in Edge Connects. So we're literally racks down from Amazon's direct connect switches. But the actual data centers that host the availability zones are like 80, 100 plus miles to the east. So you take that 80 or 100 miles zigzagging through fiber, and that actually, introduces some meaningful latency as opposed to Northern Virginia, where a lot of these data centers are a block away.
Yeah.
So
So we do have a
we do pay
question
attention.
that came into the Q&A. So from Nicola, what are the WAN link limitations for the faction storage? Minimum bandwidth and max latency.
Really, that depends on. So if you think about, if we're talking about WAN link from customer premise going into VMware Cloud on AWS, looks just like whatever you'd experience with a native SDDC. So whatever link you would use without faction storage, it looks the same in terms of site recovery. And obviously, Site Recovery Manager is fairly latency tolerant. You obviously need the bandwidth to keep up with all of your replication traffic. In terms of the faction storage, and its attachment to VMC, it's in the you don't have to worry about it bucket. We actually provision um, up to 80 gigs of traffic behind these, so dual 40 gig lags. We have an ability actually to scale up the lags even higher. Um, and then we don't. And then basically, what we're doing is we are. This is one of those things that actually makes it really economical for us to deal with this. So not only do we have dual 80 gig, dual 40 gig lags for 80 gigs of total bandwidth, but we essentially are, QoSing the storage underneath, so we know how much kind of max bandwidth people can use, and then we actually can share the traffic across those physical links, and then each customer has a completely isolated VLAN, completely isolated routing table. In fact, and this is like fun technical details from under the hood, but when VMware mounts the storage from Faction, it's basically always the same IP addresses. So we actually have completely separate routing tables for each VLAN across that link using VRF. So it's totally isolated networking, but we actually get to share that 80 gigs of throughput, which is far more than you would need for almost every storage use case.
Which is good. And I think you had a great line there, the not worry about it bucket, which I think is one of the key components of both your offering and our offering as well. Is that's on us to worry about.
Yeah, and I mean, at the end of the day, that really is, the way that we provision this and sell this is there's not any networking component to it. We sell you a number of terabytes. We give you the band, and there's a level of throughput that's expected from each tier of storage. Obviously, with the DR tier, we make that burstable, but then you don't worry about it. We plug it in. The networking that needs to come with the storage comes with the storage. It's just attached.
So along those lines, actually, another question came up from my mind, and again, everybody can ask questions, not just me. But what kind of granularity, I guess, do you guys have for the capacity? Like, can I buy? Like, what's the minimum? What's the maximum? What's the increments? That kind of thing.
Right now, we don't have a minimum. If you're buying fully managed, disaster recovery from Faction, we typically do an entry point of 100 VMs and 50 terabytes. And part of that is because our fully managed DR offering actually comes with the necessary SDDC parts included. So we actually just do it on a per VM, per terabyte. It's all in with the SDC and the storage attachment and all the networking and the management. But if you're buying the CCV product, like say what I'm in production, because we have plenty of customers that are coming to us not for DR, but just because they want to add 50 or 100 terabytes additional flash capacity into an STDC they have. So in that case, it's per terabyte, and one T is the kind of minimum increment.
Okay, so there's quite a degree of granularity there for how much, and assuming because of technology, this can be scaled on demand as well.
We do. We're not exposing a portal yet. Like I mentioned, we do have automation on our side that does this, and we're kind of getting a handle on kind of how people are using the service and doing it a little bit more, high touch at the moment. But it's fully automated on the back end, so we do expect to expose not only some scaling functions, within boundaries. It's not going to be I want to crank the meter from 1 terabyte to 500 terabytes instantly, but we do expect to let customers self-service provision up a little bit in terms of both capacity and throughput. So if you want to go from, hey, standard service level is 500 IOPS per terabyte, I want to add 50% to the performance because we're going to do some, heavy load testing or something, that you can crank that up on demand. But we're also hoping down the road, probably later this year, in that portal to expose some additional features in terms of snapshotting the backend, for example, using the array-based functions, things of that nature.
So another question popped up here. Do you guys have a trial version of this offering?
We do. Somewhere on the Faction site, and it's probably bad on me that I didn't do this, but we have been offering trials. In fact, we have a program with VMware actually where we can do full, tire kicking POCs that include both the STDC as well as the attached Faction storage, like all in one kind of evaluation bucket. But yeah, reach out, www.factioninc.com. Reach out, and we'd be happy to get you set up.
Yeah, no. So I know it's going to be, I guess, my final question here as we're coming up to the top of the hour. Is so is factioninc.com the best place to go to get a hold of you guys?
Yeah, absolutely. We've got the contact us forum, a little chat bubble, and all of those things. And this is not a lost in the shuffle thing. We're really focused on VMware, cloud on AWS customers at this point. So we love to hear from folks and work on these types of projects.
Perfect. Well, I think we're out of time. I really appreciate your time, Matt. It's kind of the Matt and Matt show today.
Right. Well, thanks for
Yeah.
having me on.
Actually, what's really funny to me is that, in our age generation, the Matthew is kind of a very common name, but I had barely worked with any, and now all of a sudden I work with like 10, and it makes for the most confusing conference calls ever. Um, but anyway, yes, I do appreciate your time. Again, everybody check out factioninc.com. You guys are on Twitter at factioninc as well, if anybody wants to get a hold of you guys there. We will be doing in office hours next week at 8 a.m. Topic to be decided, most likely, but you can join us there. And again, I'd like to sincerely thank everybody for their time. This video will be up on YouTube for anybody that wants to reference it later or share it out to their compatriots or partners or customers. And again, yes, very much thank you for your time, Matt. I think it was a really great presentation. I think it's an extremely cool offering. And it's a really nice synergy between us and AWS and you guys, and I really am very keen on trying to highlight a lot of our partners in the space so that people understand that you don't have to buy everything from VMware. There's other avenues and other offerings that can maybe fit their use cases a little bit better, but still use our technology, which I think is great.
Yeah, absolutely. I think we've been able to make a really great offering a little bit better, and I'm really excited about it. Thanks for having me on.
Perfect. And with that, I will see everybody next week. Thanks a lot for joining.
Thanks.